Hello, everyone. I can neither confirm nor deny the previous statement. So I'll just focus on what I'm here to talk about, which is comprehensions. Now, it's not only about list comprehensions. So we're going to be talking about list, dict, and set comprehensions and generator expressions, and they're pretty much up to some very important differences. They're pretty much the same thing. And I want to show you the commonality so that if you know list comprehensions, you kind of know everything else. So if computers are hard, okay, I have a clicker, so maybe I should use it. That's my face. There's also a face here, so feel free to pick whichever you prefer. You can find me online where I like to write about Python mostly. And essentially what I do is I work for a company called Textualize, working on a framework called Textual. It's really cool stuff. You should check it out. And I also spend way too much time writing about Python over here at my blog. So what is a comprehension? And to make it easier, let's start with a list comprehension, and then we will generalize. So a list comprehension is essentially a way to build lists. Please clap if this makes sense to you. That was a pretty weak clap, so I'm a little bit worried, but we'll see how it goes. So it's easier to understand list comprehensions by comparing them to loops. So let's do that. I have a loop here. Please clap if you understand what's going on. I see people who didn't clap. So that's fair. So let's just make sure we're on the same page. So there's a list here that's empty, and I'm going to go through the numbers from 0 to 9, from the integers from 0 to 9. And then over here, I'm computing the square of the integer I'm looking at, and then I'm storing it inside the list I previously initialized. So when I'm done, this list will have 10 elements, the perfect squares from 0 to 81. So there's going to be 0, 1, 4, etc., 81. So this is a pretty simple loop with an append. And I want to compare this to a list comprehension. So just let that sink in. Notice that there's similarities here. There's the num squared. You can see it on both snippets. And there's the loop over here. You can also find it in your list comprehension. So one of the things I really want to focus on this talk is that a list comprehension is kind of a simplification of the loop that I have above. Notice how I take the important bits out of the loop, the things that I selected with the rectangles, and I put them inside my list comprehension, and then I essentially I drop the fluff, the things that don't really matter. Like, why do I need to spend a line of code initializing a list? Okay, so that's pretty much like the key idea, or one of the main things that I want to stress in this talk. So if you're still keeping up, can you please clap? Thank you for the enthusiasm. That's what I'd like to hear. Okay. So this was a very specific example. I work with Python every day. I don't generally compute squares. I usually don't do it. So how do you write any list comprehension? So how do you generalize to any list comprehension? Again, let's start with a loop, an empty list, an arbitrary iterable. I'm going to go through that iterable, and I'm going to append to that new list, and I'm applying some function. I don't care what it is. I'm doing something to my element. So this is a pretty generic loop. Now, first step is you need a bunch of space in between the two brackets. So make sure to hit space a lot of times. Then you just slide in the function call, and then you slide in the loop. So this is a list comprehension, and whatever is left, you can just delete. All right, I'm not sure if you knew, but these 2 lines of code, this is not valid Python code. Do not try this. And you end up with a pretty nice list comprehension. So if you're starting out, I like to teach list comprehensions in this way. Just go with a loop, which should be simpler if you already know some Python, and then just, copy paste stuff. We're developers, we are great at copy and pasting, usually. So just do that. So that's a basic list comprehension. And now I want to show you how you can also filter data inside comprehensions. So again, let's start with list comprehensions, and then we will generalize and then we will generalize to other things. Again, same thing, let's start with a loop. And now it's pretty much the same thing, except I only care about odd squares. And so I added an if statement here. Now, will you please clap if you know what the result's going to be? Okay, so it's essentially the same thing as before, but now instead of getting 0, 1, 4, 9, 16, whatever, I only get the odd one. So that's going to be 1, 9, 25, 49, and 81. Okay, so I filtered out every other square. And to turn this into a list comprehension, we're going to go with sliding things into place again. So, except we're not. Let's start by English is hard. Let's start by comparing a list comprehension. Sorry, and then I'll show you how things just slide around. Because again, and I'm going to say this a bunch of times, so you can already fall asleep now. The main thing here is that the list comprehension is just a reordering of the loop with less stuff. And this side-by-side comparison is trying to show you that. Notice how the loops and the ifs, they're on the same line. And then what I did was I moved the squaring to the beginning. And so I'm essentially changing the focus. On the right-hand side, I have 3 lines of code and I have increasing indentation. And then in the end, on the bottom right corner, I have the transformation I'm doing. I'm squaring numbers. And in the list comprehension, if my clicker cooperates, it's not mine. So yeah, if the clicker cooperates, we can see here that the transformation was moved to the top. So we are stressing, we are highlighting the computation that we care about. So that was, again, specific example with squares. Let's take it to the general case. Same structure, new list, iterable. A predicate is just a function that returns true or false. So it's me kind of asking a question, is this element whatever? And then we get the response. And then we append if the reply is true or if the result is true. So same thing, except because now we have too much stuff. Let's just move the final bracket. We move it to the bottom. Now we're going to align everything because OCD, you don't really need to. Python will understand it if you don't align it, but let's align everything. Let's drop the fluff, which was, there's 3 changes. I'm dropping the new list.append, but I'm also dropping the colons. All right, so we drop the fluff, and there you have it. Will you please clap for this list comprehension? Yes, yes, awesome list comprehension, right? Lots of people already falling asleep, that's fine. All right, and then I hope you didn't clap because it was wrong. You need to reorder things, all right? Again, list comprehension, exactly the same as the loop, but with a transformation at the top. That's the main difference. Does it make sense? Is it making sense so far? Will you please raise your hands if it's making sense? Again, this is the main point, all right? So the list comprehension has a data transformation that comes first, not in the end, inside an append, it comes first. And then the second element, it's me specifying where the data is coming from. I cannot just create data out of thin air. So the data is coming from somewhere. And finally, there's an optional data filter. Can I point there? Yes, I can. All right, so 3 components to a list comprehension. And that's all there is to it. Like really, this is all there is to it. So if this is so simple, why would you bother learning and using list comprehensions? All right. And I would like to invite you to try and shout out at me the advantages of using list comprehensions, the ones you're aware of. Just shout. Yeah, okay, so I heard it's faster. Immutability. Okay, so that's interesting. So someone said it's an expression, not a statement. I heard it's faster, I heard it's shorter, I heard something else which I did not understand. Right, so yes, sure, also that. Just this. I also did not hear that, but I've got enough, so please don't give me any more advantages, otherwise you'll throw me off my game. So thank you for engaging with me. All right, so why bother? Yeah, well, sure, least comprehensions are faster than the loops, the equivalent loops, usually, most of the time. Again, benchmarking is hard. So usually, yes, least comprehensions tend to be shorter. After all, I literally showed you that you can take the loop, delete some stuff, you end up with a least comprehension. So it is objectively shorter. And I've added this one here. I don't think anyone said it, kind of. It's purer if you use least comprehensions properly. It's purer in the mathematical sense or the functional programming sense, because the names, the auxiliary variables you create inside the loops, they don't come out of the least comprehension. Whereas in the loop, I think it was your talk, right? Yeah, we saw yesterday, if you have like a regular loop, the auxiliary variable of the loop will be a variable outside of the loop after we're done. And they actually had a pretty weird bug at work because of that. I just forgot that I had such a, yeah, it was terrible. Yeah, so least comprehensions are pure. So there's three good advantages that people are usually able to enumerate. But I don't think those are like that's not the point. I don't think, and this is a bit subjective. This is an opinion. I don't think the point of least comprehensions is any of those things. I think the point is that they are more readable. I wrote readabler because it went well with the pattern, but English is hard. So yeah, but they're more readable. And I'm no longer stating an opinion, right? So I said, so the opinion parts was the big X here, saying this is not the main thing. Now I'm claiming that this is objective. I'm claiming that least comprehensions are objectively more readable. And now you might say, well, I thought that readability was subjective, right? Readability is in the eye of the beholder. And I'll say, yeah, but not really. And I'll show you what I mean. In this case, again, we're talking about comprehensions. We're not talking about everything in life ever. So let that sink in. Take a look at that. Can you clap if you think if this looks good? Okay, can you clap if you think this looks bad? I agree with you. I just did something. Okay, I agree. So now let me show you something else. Let me show you an equivalent least comprehension. Now, I'm not saying that this is good. Okay, both. What did I do? Oh my gosh, I just changed my pointer. Amazing. Yeah, so I'm not saying that either is better than the other. I think they're both terrible. But this shows two really important things. First, it really hammers home my point of notice what's at the top of the least comprehension versus what's really hidden inside the nested loops. It's the thing we're doing, the data transformation. The thing that actually ends up in your list at the end is going to be the func of V1, V2, V3, V4, V5. And in your list comprehension, it's right in your face. It's the first thing you read. In the loop, you have to go through, I don't know, maybe 10, 12, 15 lines of terrible code. And I was pretty nice, and I reduced indentation to a single space. So if this were 4 spaces, you would have to scroll right, unless you have a monitor this huge, this big. English is hard, again. So yeah, and it also shows something else, which I didn't mention before, which is a least comprehension can have more than one loop and one filter. All right, you can actually nest them arbitrarily, as this example shows. And if you want to turn that into a least comprehension, what do? You get rid of the appends, you align everything, you delete all of the colons, and you move the transformation to the top. Least comprehensions are so simple that you should be able to take a nested loop and just turn it into a least comprehension with your eyes closed. It's that simple. Because it's a mechanical thing. It's just align, delete, and drag. Does this make sense? You should know by now that you should clap. So does this make sense? Okay. At this point, I'm not sure if I'm just bullying you into clapping but yeah. So let's take a look at some examples of what I think are good comprehensions and good use cases, because it's very easy to go nuts and write terrible comprehensions like this one, and then someone on the internet will say, yeah, but this is readable because it's a least comprehension. Well, yeah, well, it is a least comprehension. I don't think it's great. So let's try to avoid this thing. So let's take a look at some things that I think, and then subjective stuff kicks in, I think are good examples. So let's go with this one. And these are not theoretical list comprehensions, all right? These are, who said freshly sourced? So this is freshly sourced from the CPython implementation of the email, module. So this is real code running in your computer. And this is a pretty simple list comprehension. I mean, what's there not to like? Would you rather have 3 lines of code instead of this? The complicated thing here is this thing, if we can call it complicated. I mean, it's just a loop over some integers, and then we do some string formatting. Why do I need to hide it after a for loop ends and appends? Like, what's the point? In here, I can focus on what matters, which is parsing this very old string formatting, right? So this is a good example of a list comprehension. It's a simple list, a simple transformation. You just go through some, I don't know, some range, some simple iterable, and you create some new stuff. This is the archetype of a good list comprehension. Now, another thing I really like is this. So let that sink in. Let's see if you can understand the mechanics of what's happening. I'll just pose for the photos now. Yes, excellent. All right, now one where I'm pointing. Can we do one where I'm pointing? Excellent, thank you very much. So, I mean, I gotta feed my social media, right? So what's happening here? Who can shout what's happening here? You were all distracted by my poses. No one? So what's happening here is we're flattening a list of lists. So if you look closely, exceptions is going to be iterated over, and then I'm going to iterate over the sub. Notice how sub came from exceptions, and then I'm taking the exc from sub, and I'm just putting it there. So I'm flattening a list of lists. And I think this is a pretty neat way of flattening two lists. There's like a crazy quote unquote trick with some. It's quote unquote trick because it's not really a trick, but that's like a whole nother talk. So this is a pretty standard way. There's some other tools that do this like lazily from iter tools or whatever, but this is a pretty decent way of doing it. And again, this is real code from async.io. So it's not like a theoretical example. This is actual code that runs. Everyone with me so far? You should clap by now. Yes, thank you. You're paying attention. Thank you. Alrighty, so one other I really enjoy. So self.flags is a dictionary, and I'm taking the items. And then I'm going over the items, and I'm taking the keys as sig and the values as v. And I'm just extracting the keys with a condition on the values. And the pattern I like here is me filtering data with an auxiliary filter. So essentially what I see here is two sources of data, which is all of the keys and all of the values. And I'm picking some keys depending on some values. And you don't need to have a dictionary here. You could have two different iterables, you zip them together, and then you keep the elements of one depending on what the elements of the other give you. So this is a pretty decent, what do you call it, example, use case. Yeah. Again, so now tooting my own horn just a little bit. This is from textual, so this is code that I didn't write, but I've been close. So if there's a bug there, it's probably my fault. And this is a pretty standard use case as well. Notice how there's the underscore here next to the range. So the underscore here isn't doing anything magical. It's just an idiomatic way of saying, I don't really care about the current iteration I'm in, because I'm going to be doing always the same thing. And so what I'm doing here is creating a list with a bunch of things inside that are always the same. So if you need to initialize a list with a bunch of elements that are always the same, this is a very standard way of doing so. Personally, I use this, for example, when I need lists of random integers. Or I don't know, when I need to generate a random caller, like an RGB caller, I'll create a random caller on the left and then go over range 3. Pretty standard pattern. And another one I like, and to me, again, subjective, to me, this is like as far as I would go with the list comprehension, which is, you know, maybe not a trivial iterable. So you're doing something to the iterable. In this case, I'm just reversing something. And I have a predicate here. Again, the predicate is hidden, but I'm not doing a function call, but I'm checking something. So I'm checking if the rule is here. And it's fine if your least comprehension spans over 1, 2, 3, 4, 5 lines. The point of least comprehensions is not to make it shorter, to have it on a single line, because it's very easy for a least comprehension to go over whatever recommended maximum width you go with, either 80 or 90 or 10, which is the minutes I have left. So it's not the point. The point is that the least comprehension dropped the fluff, right? So after you drop the fluff, you can make it span across multiple lines. That's fine. You're not charged, like, I don't know how it works at your job, but I don't make more money or less money if the number of lines of code I write changes. So it's not like I have a financial incentive to either make it span more lines or less lines. So just let your code breathe. So I like this least comprehension. Can you, now this is okay if you don't clap. Can you clap if you like it? Does it look good? Thank you. Some enthusiastic claps from the audience. So I appreciate it. Thank you very much. They didn't go unnoticed. Alrighty. So now let's take a look at two patterns that I see often with beginners. And I mean, it's fine. I'm not judging you because you made it. I'm just letting you know that I look for this because I already know that people do this. And I already know that I have to explain them. This is not really the point. And I explain, well, this is not the point because. So what's wrong with this least comprehension? Yes, I heard both things. I would scream both things inside my head, but if I'm explaining it to a beginner, I wouldn't go, it's nothing, or side effects. Yeah, but that's both the bad things that are happening here. So print has side effects. When you call print, something happens elsewhere. It might be in your terminal. You see something. And at the same time, like this least comprehension, whether you assign it to a variable or not, will not affect the final outcome. And the point of a least comprehension is to build a list. So if you're building a list and you're throwing it away, why are you building the list? So if you're only using a least comprehension for the side effects of the function you're calling, that should be a loop, period. And yes, it's subjective, but it's not subjective, okay? So if the point is side effects, use a loop, because again, and I'm not trying to be authoritarian. English is so hard. Yeah, whatever. I'm not. Yes, I mean, it doesn't. I work with English every day. I used to be good at it. Now it's just, it sucks. So I don't know where I was going. So maybe I'll skip the slide. Let's see. Yeah, it's kind of, it's a contract. If I write a least comprehension, my teammates will immediately know, because we trust each other, that I'm not doing side effects, because the point of the least comprehension is to do a pure computation. It's like a social contract. So yes, it is subjective. You can use least comprehensions for side effects. But the vast majority of people will respect that contract and expect you to respect it because it makes life easier on all of us. And the second thing I don't like is this least comprehension. I see it a lot. It's not terrible. Like if you're a beginner and if you make this mistake, this is like the best mistake you could make because you're almost there. If you're writing something like this, where the only thing you're doing is taking the value out of the iterable, just call list on the iterable. It has the same effect and it's shorter, cleaner, faster. Yeah? Does this make sense? Thank you. So how much time do I have left? Not a lot of time. And it feels like we still have a lot to cover, except that we've already covered everything that matters because now everything just falls into place and I'll show you. Sit tight. So let's go over set comprehensions. And let's start by taking a look at a least comprehension. Let's see how to turn it into a set comprehension. You can clap now. To write a set comprehensions follow all of the same rules and conventions, except you use braces instead of brackets. Does this make sense to you? It's the only child. Thank you. Thank you. Yes. You know the dynamics of this better than I do. Yes, exactly. So that's all there is to it. Really, that's all. Now, it's a whole nother story if you need to know when to use sets, and that's fine. That's material for maybe another talk. There's also a, what do you call it? A chapter. I have a free, sorry, let's not hide that. I have a free Python book because I learned Python online for free, so why not share some knowledge for free? There's a chapter in there about sets, so feel free to take a look. Now, dictionary comprehensions. Sorry, I'll show the QR code once more so you'll have time. Just have your camera ready. So let's take a list. How do you turn this into a dictionary comprehension? Well, this was faster, but it's also not that much. So I changed the brackets into braces. I'm sorry I couldn't keep your interest. It's a shame. It's fine. And so now what I'm doing is, instead of having a single element in my data transformation place, what I do is I can do something to create the key. So an arbitrary function, then colon, and then an arbitrary function to create my value. And usually you see this like this. You can, like, it's functionally it's the same, but it's easier to maybe see it this way. There's going to be something here, maybe a zip with something, you get values, and then some of them become keys and some of them become values. Does this make sense? And again, that's all there is to it. Really, it's that simple. Now, generator expressions, these are fun. I could do a bunch of talks on this, on generator expressions. And to turn a list comprehension into a generator expression, I just did it. Can you see what changed? The braces become parentheses, and that's it. This is a generator expression. It's the same as a list comprehension, except it has some other differences, but that's because of generators, not the comprehension part. And again, that's all there is to it. Really, thank you. Nice. All right, and generators are not that weird. There's a bunch of similar things that are built in, so you probably encountered any of these, and they're very similar to generators in principle. So if you want to work with these things, there's a workshop tomorrow that I'm giving about comprehensions. So feel free to drop in. We'll practice a lot. And I will be writing about generators in the book I mentioned. I just haven't yet because Python is huge. So this is the same QR code as before. I will have a chapter on generators eventually. And yeah, just to make this click, just practice, because that's how things click. You know, again, there's workshop tomorrow. I was afraid I might forget. I'm being bullied into stopping. And if you cannot attend the workshop, for the workshop, I'll be just taking a bunch of exercises from a book I wrote on this. So this is the QR code to the comprehensions book. I've been pretty obsessed about this topic. It's an interesting story. You can ask me about it later. Pause for the QR code. 1, 2, 3. Excellent. Finally, thank you for your attention.